Well, here are a few problems from rotational motion, and these are typical problems that involve formulas for angular acceleration, angular velocity, centripetal force, and so on. Let's jump straight away into the first question. Pretty straightforward question. It talks about a dentist drill that starts from rest, and after 3.2 seconds of constant angular acceleration, it turns at a rate of 2.51 times 10 to the 4 RPM. Find the drill's angular acceleration and find the angle through which the drill rotates during this period. So the first sentence says it starts from rest. That proves that the initial angular velocity is 0. And after 3.20 seconds, that's the time, it turns at this RPM. So from that RPM, we can find out how many revolutions it makes in a second, just dividing that number by 60. And once you get that, because each revolution is 2 pi radians, when you multiply it with 2 pi, you will get the angular velocity. So initial is 0, time is given, and the final angular velocity, like I explained, is 2 pi times the frequency, which means the number of rotations per second, which is that divided by 60. So when you do all that, you get 2.63 times 10 to the 3 radians per second. So now when you look at these terms, the equation that is to be used is obviously the difference in angular velocities divided by the time. Which gives 821 radians per second squared. In the B part, you have to find the angle through which the drill rotates during this period. If we find theta, or rather to find theta, we can use this equation. And the first term vanishes because omega naught is 0. So you just have 1/2 times the alpha that we just got now times the square of the time, which gives 4,210 radians. Here is a second question. This question talks about a centrifuge that rotates at an angular speed of 3,600 revolutions per minute. And when it is switched off, it rotates through 50 revolutions before coming to rest. Find the constant angular acceleration. This is, again, a straightforward question because once you find the frequency, you get the initial angular velocity. And the final angular velocity is 0 because it says it comes to rest. And it makes 50 revolutions. Now 50 revolutions is 50 times 2 pi radians. So 50 revolutions is 2 pi times 50 radians because each revolution is 2 pi radians. That gives us 100 pi as theta. And so now to find alpha rather, we use this equation. Rearrange to make angular acceleration the subject. Substitute the numbers. Well, when I cancel that, I mean to say I'm canceling one of the pi's. Okay, so it's 120 squared, so don't miss that. There is 120 squared there. I mean to say that one of the pi's are cancelled. So that gives negative 226 radians per second squared. Now, before we go on to the next question, it's important to review certain formulas, starting with the definition of an angle, from which we get the length of the arc is the product of radius and the angle. That comes from the definition of an angle, because angle is length of the arc divided by the radius. So, considering the changes in these three quantities, we're going to have to say that the radius is a constant because we're considering an object moving in a circular path with a constant radius. So the only two quantities that can change with time are s and theta. So with that gives delta s by delta t is r delta theta by delta t. Now delta s by delta t is actually the tangential velocity, and delta theta by delta t is the angular velocity. So the velocity is always tangential, so this is called the tangential velocity. And so we get this formula. Now from this formula, once again considering the change with the time, you get, remember that radius is constant again. So this term now becomes the tangential acceleration, and this term becomes the angular acceleration. So now we have the second formula. That is, tangential acceleration is radius multiplied by the angular acceleration. It's also important to remember that in every case of circular motion, there is what we know the centripetal acceleration. The centripetal acceleration acts towards the center of the circle along the radius, and therefore it is also called the radial acceleration. Now it's important to know that the tangential acceleration is not the same as the radial acceleration, which is very clear. The tangential acceleration is along the tangent, while the radial acceleration is along the radius. That's one point. And number two, if an object is moving with a constant angular velocity, then there is no tangential acceleration because the tangential velocity is constant. But even then, we have radial acceleration. So radial acceleration always exists, while tangential acceleration happens only when the object is either speeding up or slowing down. So there are two accelerations, like I mentioned. One is the radial acceleration, the other is the tangential acceleration. And we know that the centripetal acceleration is given by v squared by r. And again, if omega is constant, tangential acceleration is non-existent, but even then we have the radial acceleration. So here is the next question. What is the tangential acceleration of a bug on the rim of a 10-inch diameter disk if the disk moves from rest to an angular speed of 78 revolutions per minute in 3 seconds? When the disk is at its final speed, what is the tangential velocity of the bug? And 1 second after the bug starts from rest, what are its tangential, centripetal, and total accelerations? All right, take it one at a time. First of all, the 10 inches has got to be changed into meters. And second, we know that the initial angular velocity is 0. And the final we can find out just like we did in the last two problems. So change the revolutions per minute into revolutions per second, and then use omega is equal to 2 pi times the frequency. Now 1 meter is 39.37 inches, which gives 10 inches as 10 by 39.37 meters, which is 0.254 meter. So the idea is to find the tangential acceleration. We have to have the radius and alpha. Now radius is already given directly, that's 10 inches, which we have found. So we're looking for alpha. And to find alpha, we use this equation, change in angular velocity by time. And I am dividing by 60 because you got to have the revolutions per second. So when you do that, we get 2.72 radians per second squared. Now plug it back into this relation, multiply it with the radius, and you have your tangential acceleration as 0.346 meter per second squared. Now in the B part, you're asked to find the tangential velocity of the bug when the disk is at its final speed. All right, so we know the tangential acceleration we can find the tangential velocity by using r omega. And it gives you 1.04 meter per second. That is the tangential velocity. Now C, 1 second after the bug starts from rest, we know we can still use AT is R times alpha, because alpha is a constant. So we have 0.346 meter per second squared. And then to find the centripetal acceleration, you have Vt squared by r, from where you can find Vt from this equation, V0 plus A times t gives 0.346 meter per second. So plug it back into this relation, divide by the radius, and you have the answer, 0.943 meter per second squared. The total acceleration is just found by taking the square root of the sum of the squares. And what is the reason? The reason is that the tangential acceleration and centripetal acceleration are at right angles to each other. And when you have two vectors that are perpendicular to each other, you find the vector sum by taking the square root of the sum of their squares. So that gives 0.346 squared plus 0.943 squared, which comes out to be exactly 1 meter per second squared. Here is the last problem for the day. A 40-kilogram child takes a ride on a Ferris wheel that rotates 4 times each minute and has a diameter of 18 meters. What is the centripetal acceleration of the child? All right, frequency is 4 divided by 60 because we want it per second. Find omega. Get 0.105 radians per second. Find the linear velocity using r omega. And once you get that, find the centripetal acceleration using v squared by r. So that is the velocity squared by the radius, gives 0.099 meter. Oh, so I made a calculation mistake there. Oh, I forgot to multiply with the pi, and I again forgot that now. So now I've changed the answers because I had forgotten to multiply with the pi. So centripetal acceleration happens to be 1.58 meter per second squared. Okay. The next part is, what is the force, or what force does the seat exert on the child at the lowest point of the rider? At the lowest point, the forces acting are the weight, mg, down, and the normal force up, and the net force is N minus mg, because N is positive, mg is negative. That should be equal to mass times acceleration. And ma is positive here because it's towards the center of the circle, which gives N is the sum of ma and mg, taken out mass, and then gives 9.8 plus 1.58, and you get the normal force, which is the force exerted by the seat on the child. You get it as 4.55 Newton, 455 newtons upwards. So that is the answer to that. I think I forgot right newtons. Okay. In the C part, what force does the seat exert on the child at the highest point of the rider? Let's go to the next page. At the highest point, the forces acting are again the normal force up, the weight down. But this time, remember that the centripetal force is towards the center, which means it's acting down. So you got to put equal to negative ma, which gives N is mg minus ma. And so it comes out to be 329 Newton upwards. Now the D part says, what force does the seat exert on the child when the child is halfway between the top and the bottom? Halfway, okay. When the child is halfway, here are the forces. Weight, always vertically down, and you have the normal force, normal to that point in the circle, means perpendicular to that point. And therefore, since both are at right angles, you've got to find their vector sum now. And the green arrow gives the total acceleration, or total force rather, in this case, which can simply be found by taking the square root of the sum of the squares. And so mg is 392 newtons, and mac is 63.2 newtons. So when you do the math, it comes out to be 397 newtons. And tan theta here is opposite side by adjacent side. Opposite side is mg, the adjacent side is 392. So when you do that, you will get the value for theta. Take the tan inverse of 6.2. That's quite a big angle. That's 80 degrees to the horizontal. So those are the 4 problems. I hope you understand these. There's quite a bit of repetition in these problems, and that is just to give you more practice on using these formulas. Thank you.